Okay, so we're going to take a look in this video at vectors. So when we would say vectors in terms of this class, we're referring to something that looks something like this, right? Just kind of in space, right? Where we have between 2 points P and Q, right? So it's defined by what we see as an initial point and a terminal point, which in this case is Q. Okay. So what defines a vector is its magnitude, right? Or what we geometrically is called the length, right? So from P to Q, right? So it has a sense of direction and length, right? Now here it's important to recognize that here as you can see where the tail, where the initial point and the terminal point, what we call those is going to be important, right? Because the arrow is pointing where the terminal point is. All right, now in terms of here, we just kind of abstractly we think of a vector out in space here, but if we refer to it in terms of our coordinate system, our rectangular coordinate system, where let's say point P has coordinates x1, x2, and we have point Q somewhere out here, and x1, y1. And Q will have x2, y2. And we have our vector PQ to be defined in that manner, right? In space between those 2 points. All right, and again, there is a difference here if we want to define the point QP, or the vector QP, excuse me, would be this point going in this direction. Okay. So those are the characteristics of our vectors, right? They have an initial point and a terminal point. Right now, we saw this direction, this notation, excuse me, where we have PQ and we have an arrow over the top of it. Now, other types of notations, if let's say we name this point, this vector U, right, we'll sometimes see, right, just the notation with the U and an arrow on top. Right, and sometimes now it's kind of hard to write that on here, but in your textbook you may notice here that they'll use boldface type, where they'll use the letter and it's written as boldface. Okay, now here the boldface, the arrow over it, or the 2 points here we'll use to define what a vector is, right? Now notice that it is much different than a point in our coordinate system. A point has coordinates x and y, that's it, right? A vector is defined by 2 quantities, right? The magnitude, right, which we call its its length and its position. All right, the magnitude, its length, and its direction, not its position, its direction, right, in which direction it's going. Now, here, we are going to define something that is called standard position. Okay, so let's say that we do in fact have, let's put some numbers here, these 2 points here. All right, so let's say P we'll define to be 0.23, and then Q we'll define to be, let's say, how about 8, 6. All right, so these are 2 points here. All right, and now let's graph these here, right? All right, so let's say P is a 0.23, so 1, 2, 1, 2, 3. So we'll call this P, and then Q is 2, 3, 4, 5, 6, 7, 8, 3, 4, 5, 6. So somewhere out here, right? So that is Q, and if we define the vector PQ, that looks something like this. All right, now we would like to have some kind of mathematical formula, some kind of way to perform operations on these vectors, right? So we see that they live in space. So the way we're going to be able to do that is to write or draw, in some cases, the vector in what's called standard position, right? So I'm going to define this vector u, and the way I'm going to calculate, and here I can do this to any vector, right? The way I want to calculate u, so a couple of things here, is u, I'm going to write it in terms of the difference. So I'm going to use this notation here, right? This kind of arrow bracket here, and the x value is going to be the difference in the x coordinates. Now here the position here is going to be important, right? It'll be the terminal point, the terminal x coordinate minus the initial x coordinate, and the terminal y coordinate minus the initial y coordinate. All right, so for these particular points P and Q that we have, Q is the terminal point, so our vector u is going to be the vector 8 minus 2 and 6 minus 3. All right. Six, 3. Okay. All right. Now notice that this vector u, it's what we call in standard position. So this is not a point, right? So when I go to graph something like this, so what this looks like here is we'll go 6 in the x direction, 1, 2, 3, 4, 5, 6, and then 3 up here in the y direction. So it's somewhere here. All right. Now, this is not, like I said, it's not a point, it's a vector, but in this case, when written in this form here, where we just have the those curly brackets, those arrow brackets here, the initial point is always going to be the origin. All right? And this represents the vector u. All right? Now the vector u and the vector pq, right, they both have the same magnitude and the same direction, right? So same length, same direction. The only difference here is u, it's what's called is a position vector. It's in standard position. All right. Now, whenever we see something that's written like this, right, it's not a point, it's a vector, and that initial point is always going to be the origin. Okay, and this kind of helps us to kind of standardize the whole vector process, because now we can, knowing that if we're dealing with standard position or position vectors, we can now start to define quantities like adding vectors, subtracting vectors, right? And I don't have to worry about, well, where are they in terms of the coordinate system, right? Even though, as we can see here, that vector u can be present throughout different places in our coordinate system, right? It's just would be labeled something different, right? It'll be defined by the points, whereas here we're strictly defined in standard position, right? So we're able to compare it to other vectors or perform operations using other vectors as well.